Hello friends, today video will be on plotting the vertical stresses on a vertical plane or on a vertical line. So let's say that there is a surface load of magnitude Q. This Q is acting at the ground level and this becomes Z axis and depth is also in the downward direction will be Z. Now, on any vertical plane or on a vertical line, if I want to calculate the vertical stresses, so I want to calculate sigma V or sigma Z. Vertical stress on a vertical line. As shown in the figure. This vertical line is, say, at a radial distance of r. So this becomes the radial distance. From the axis of loading. How will you calculate it? As we know that vertical stress sigma Z is given as the Boussinesq influence factor into the point load divided by Z square, or it can be further written as 3 divided by 2 pi into 1 upon 1 plus r by z whole square pi by 2 into q by z. In the last video you have seen this expression given by Boussinesq. Now, if you simplify it, this can be written as 3 divided by 2 pi into, here it becomes z square, so this becomes z square plus r square, and the denominator z square will go here, z square pi into q by z square. Further, if we simplify, this is going to be equal to 3 divided by 2 pi into this numerator is z square, and if you take the power 5 by 2, so 2 goes out, this becomes z5. So you can take it out. So this becomes z power. So here z square on the numerator multiplied by 5 by 2 gets cancelled. So it becomes z raised to 5. This becomes 3 divided by 2 pi, and this z to the power 5, we have taken it out, divided by 1 upon z square plus r square 5 by 2 into 2 by z square. Now this z square, and here it becomes z cube. So finally what you get it is here that it can be further written as 3 divided by 2 pi into z cube divided by r square plus z square raised to power 5 by 2 into right. So 3q by 2 pi, you can write it. This is finally equal to 3q by 2 pi into z cube divided by r square plus z square raised to power 5. In this form we have got it. Now for a vertical plane, we can find out for any given depth z, we can calculate all the values, and therefore we can calculate sigma z. Now if you want to find out the maximum vertical stress at what depth, the maximum vertical stress along this vertical line is going to take place, we want to find the depth z for the chosen vertical line for maximum vertical stress. How will you find that? So you want to find out the depth z at which the vertical stress is going to be maximum. That means if this is the final expression for sigma z, for maximum, for maximum or maximum vertical stress of sigma z, d sigma z, d by dz of sigma z must be equal to 0. So already we know sigma z equal to 3q divided by 2 pi. This q for given value of q. Now this is going to be constant. So here if you want to take d by dz, differentiate it, then you should differentiate d by dz of this term z cube divided by r square plus z square by 2 must be equal to 0. Very simple. So it's of the form d by dz of u by. Right. So how will you find out? If you differentiate it, there is the numerator, there is the denominator, and then it becomes v into d by dz of u minus u into d by dz of v, u into this, and because it is going to be 0, the denominator doesn't carry any meaning here. So here this has to be 0. So applying this logic, we can find out the derivative. This is going to be u and v. So v into, that means we can write it or r square plus z square pi by 2 into dz cube z minus z cube into d by dz of r square plus z square 5 by 2 must be. So if you differentiate, you can further simplify it. R square plus z square 5 by 2 into 3 times z square minus z cube. Now this can be written as d by d r square plus z square of this term r square plus z square 5 by 2 into d of r square plus z square divided by dz must be. I hope this point is very clear. Denominator we are not taking because anyway it's going to be equal to 0. So you multiply now. If you further simplify it, how will you do it? This becomes r square plus z square power 5 by 2 into 3 times z square minus z cube. Now this will be how much? 5 by 2 into r square plus z square to the power 3 by 2 into r is constant. Say r is here constant for a vertical plane. Let's say it is equal to 1 unit. So it's going to be constant for a vertical line. Naturally, here it becomes 2 times z equal to 0. So on a fixed vertical line at a fixed distance up, the maximum value of sigma z can be found out from this expression. So here finally you have got here r square plus z square 5 by 2. Here you have r square plus z square into this 3 by 2. So you can take it out this one. So r square or r square plus z square 3 by 2, let's take it common. So here what remains is r square plus z square. Okay? If you multiply it, so it becomes 5 by 2. So here remains this into 3 times z square minus, now this is z cube and this is 2 goes out. So this becomes 5 times here r square plus z square into 3z square minus z cube. So this is going to be 5 times r square plus z square and this z cube and z, this becomes z4, z cube into z, that becomes z4. So 5 r square plus z square. This has been already taken it out. 3 by 2 we have taken it out. So this term will not come. So what is going to be finally? This has been already taken out. So it becomes 5 times z4. Must be equal to 0. So further simplification, if you make it, what will you get? So here from this amply clear that r squared plus z squared into 3 times z squared minus 5 times z4 equal to 0. So now if you simplify it, this becomes here what's going to be common is z square. So z square can be taken, or r square plus z square 3 times z square has been taken out minus 5 times z square equal to 0. So, or 3r square plus 3z square minus 5z square equal to 0. So, if you further simplify it, so 3r square equal to 2 times z square, or r by z square, r square by z square, that is r by z square equal to 2 by so you get this r square by z square equal to 2 by 3, or r by z or r by z equal to under root 2 by 3. So this is the, or we can say that we take 2 divided by 0.816. So z equal to, or z by r equal to this 1 by x. If you take it, then it becomes 1 divided by 0.816, 1.225 units. So r is z equal to, therefore 1.225 into r units. So the maximum sigma z maximum will be at z equal to 1.225 times r units. So z is going to be, if I take r equal to 1, then z will be 1.225 units. What are you equal to? Unit. So z equal to 1.225, the vertical stress will be maximum. Maximum vertical stress is going to be at a value where this z value is going to be 1.225 units. That means if I join on the vertical line, here it is sigma z is going to be maximum. This is if I join it from point O, the point of application of the point load, to this point, and we can find out this angle. Tan beta therefore will be this distance, that is r divided by z. So for maximum value, the value of beta r is 1 unit and z is 1.225 units. Therefore, for maximum value, the beta value will be tan inverse 1 upon 1.225. So if you calculate this, tan inverse it is giving you approximately 39 degree 50 minutes. So this is the value of beta. So beta equal to 39 degree 15 minutes. At this angle, you will be cutting the maximum value of sigma z, and sigma z will be at maximum value will be at z equal to 1.225 units. This is how theoretically we can calculate in a simpler way. In the next video, we will try to solve some of the examples on this. Then things will be more clear. Thank you.